Alright, so yesterday we did 9-1. Today we're going to do 9-2, adding and subtracting rational expressions. Our homeworks are number 20, 22, 28, 29, and 30. So we open up to 9-2. Our learning target, I can determine the LCM, and that's the least common multiplier of polynomials, and add and subtract rational expressions. So what we're doing here is a lot what you've done before in your elementary years, middle school years, early high school years. And it's finding the LCM. The LCM is the least common multiplier. And what we're doing is, you've done this before with fractions. Say we have a half times or added with a third. No, so we have a half plus a third. What do you need to do? Oh, you need to make the bottoms the same. So let's go with 6. 6 is that LCM. That's that least common multiplier. All right? So I multiply by 2 here, multiply the top and the bottom by 3 by, how can I get 6 on the bottom for both of these? So now I have 3, 6 plus 2, 6 equals 5, 6, and there's my answer. All right? So that is the idea. Can you get the least common multiplier? So for this, same thing. What is the least common multiplier? So 12, 15, 8. What is the number that all those go into eventually? And that number is 120. Now it's easier to do when you just have 2. I had to do some playing around with trying to figure out, okay, 12, 15, 12, 24, 36, going all the way up. Okay, is there something that 15 hits and 8 can get into, and it's finally 120. And then here, the most number of a's we have is squared, so a squared. For b, it's b to the third. Now, this has 1b, this has 1b, but this has 3 b's. So this is kind of like what all these have to encompass this. Or this has to encompass all of these. And then c, we have c to the fourth. All right, so this would be your LCM. Now for these, a little bit more difficult, you have to factor. So for this, I'm going to pull a 4a out. Anytime you notice that there's a 4 in front of here, check these to make sure they're divisible. Not an a, sorry, just a 4. And now we have a squared minus 3a minus 4. And then I have 4, and then it's a minus 4a plus 1. And for this one, this is where we can pull an a out. Now we have a squared minus 9a plus 20. So you're thinking, all right, a minus 4, a minus 5. We're just factoring. And now we got to make sure our least common multiplier has all these in it. So we need a 4. Good. We need an a on the side as well. We need an a minus 4. We need an a plus 1. And we need an a minus 5. So all these are encompassed into this least common multiplier. That's how you do that sort of problem. All right, so now that's just, can you find the LCM? We're going to need to be able to find the LCM when we are adding and subtracting rational expressions, like this example right here. Now, what is the LCM here? And this is where you're going to decide, all right, how can I get these to be alike? Well, 5 goes into 10, so 10's perfect. I need a to the third, and I need a b squared. So this is my LCM. That's kind of your first step. Find the LCM. Good. And now you're just going to multiply the top and the bottom by however you need to get to the LCM. So for this, I just need to multiply the top and the bottom by 2. Right? 2 here will get me 10. 8 times a to the third times b squared. So now I have 8 over 10 times a to the third plus b squared plus, and here I have the 10. I need to multiply by 2 extra a's and a b. So a squared times b, a squared times b. So I have 9a squared bc over 10a to the third plus b squared. And now you can just add So we have 8 plus 9a squared b c all over 10a to the third plus a to the third. Oh, there's no plus here. There we go. Times b squared. Yep, there should not be a plus right there. It should just be 10 times a to the third times b squared. And that's what you can do there. Now, if you broke these up, you could simplify this, but this is where I need you to be. The second part, then, polynomials with denominators, actual polynomial ones. And here, we need to find the correct LCM again. So the LCM here. This is going to be where we're going to need to factor this. So 4x squared plus 21x plus 5. I need to find two numbers that multiply to 20 and add to 21. Well, 20 and 1. So I have 4x squared plus 20x plus 1x plus 5. Group those. Oh, there you go. Sorry about that. You can take out a 4x on this left one. So you have an x plus 5. And you take out 1 and you have an x plus 5. So you have 4x plus 1 and an x plus 5 here. And for this one, if you take out a 3, you're left with 4x plus 1. That's perfect because that takes out care of that. So our LCM then, 4x plus 1, x plus 5, and a 3 on the side. So that's our LCM. That's what we need our bottoms to become. This bottom is just the 4x plus 1 and x plus 5. So we just need to make sure we multiply by 3 on the top and the bottom. This one's going to be a little bit trickier because it's just the 3 times 4x plus 1. So we're going to need to multiply by the one we're missing, x plus 5, x plus 5. So now on the left here we have 3x minus 24, right? 3 times x, 3 times negative 8 is 3x minus 24. All over, I'll just put the least common multiplier right there, just LCM. We know that it's this. I'm just going to put it right there to save time. Plus, and then 6 times x is 6x. 6 times 5 is 30. And then we have that, or the LCM. So we can add these together. So 3x plus 6x is 9x. Negative 24 plus 30 is 6. Now I'm going to actually write it in the least common denominator. So we have 3 times 4x plus 1 plus x plus 5. And now this is basically 95% done, but I can use this 3 and I can simplify this a little bit more. Right, so 9 divided by 3 is just 3, 6 divided by 3 is 2. So our final answer is 3x plus 2, and 4x plus 1, and x plus 5. There's a lot going on. There's a lot little steps involved. It's very, very particular, but in the end, it's just adding fractions. All right, so work on some problems. We're not going to worry about this or this, but work on that for the weekend.